As I said before, we can't make acids simply by mixing carboxylic acids and amines. If you do that, you're only going to see a very fast acid-base reaction to get this salt. If we want an amide from something like this, I need to first make it into an acid chloride. All right, from there, now I can react it with some amine and get the amide in pretty high yield. But how do I do that? Right? So acid chlorides are always made from carboxylic acids, but how? So I want to go through that mechanism right now. We make acid chlorides from carboxylic acids using thionyl chloride, SOCl2. If you look at what SOCl2 looks like, it kind of looks like an acid chloride itself, right? It's got a really electron-poor sulfur atom here that some nucleophile is going to want to attack. So you won't have to memorize this mechanism, but I do want to show it to you because it's pretty intricate and I think it's cool. As I said, sulfur here is really electrophilic, so my nucleophile is going to be this oxygen. It's going to come in, force a new tetrahedral intermediate here. This tetrahedral intermediate is then going to break down, losing a leaving group, as these things often do. And as I lose this acid proton and Cl, so you could think of this as losing HCl, I guess, you'd get to this looking thing, right? It looks kind of weird, but if you squint, it sort of looks like an anhydride, right? You can almost look at this whole thing as a leaving group. So what we've done so far is we've taken this OH, which is not a leaving group, and essentially turned it into this SO2Cl, which is a leaving group. So we've managed to make it into a leaving group in one pot, right? We didn't have to take two steps. Well, now what? So now I've got a leaving group. Is there a nucleophile in the pot? Actually, the nucleophile is going to be this chloride that I just kicked out. So my chloride is going to attack here. I'll get a new tetrahedral intermediate over there. So here's my new tetrahedral intermediate. Now I've got two possible leaving groups here, this chloride and this sulfur-containing leaving group. Again, this whole thing is a leaving group. Not only is this a better leaving group than chloride, it actually falls apart when it leaves. So these electrons come down and actually form SO2 gas and then kick out more chloride ion. So that's how I make acid chlorides from acids. It's actually kind of a cool reaction. Usually this carboxylic acid is not soluble in whatever solvent you're using, or it's only barely soluble. And then you add a little bit of your thionyl chloride. Maybe you even use thionyl chloride as your solvent. And you cook it up. You see lots of little bubbles and gas escaping. That gas escaping is your sulfur dioxide, so that tells you that it's working. And then eventually all your stuff will be soluble in your solvent because this nonpolar acid chloride is much more soluble than your acid.